This is a video on intersection of lines. The question states, determine if the lines intersect. If they do, find the point of intersection. We have our two lines. The first line is x is equal to 3 minus 2t, y equals 4 plus t, and z equals negative 2 plus 5t. And the second line is x equals negative t, y equals 7 minus t, and z equals negative 1 plus 9t. If the lines intersect, that means that there's a time t for the first line and a time t which might be different for the second line, at which we get the same point x, y, and z for each of the two lines. So I'm going to call the time for the first line A, and I'm going to call the time for the second line B. So let's notice that if we get the same point, that means the x coordinates, the y coordinates, and the z coordinates are all the same. So that means if I plug in A for t for this first x equation and B for t for the second x equation, I should get the same value. So that means I can set them equal to each other. In other words, 3 minus 2 times A should be equal to negative B. And the same is true for the y equations. If I plug in A, I get 4 plus A, and that should be equal to 7 minus B. And for the z equations, if I plug in A, I get negative 2 plus 5A, and that should be equal to negative 1 plus 9 times B. So this gives me 3 equations and 2 unknowns. This may or may not have a solution. But if it does, that means I can use algebra and solve. So I'm going to use the second equation. It looks the simplest. I'm going to subtract 4 from both sides. 7 minus 4 is 3, so I get that A is equal to 3 minus B. So I could plug 3 minus B in for A into this first and third equations. So if I do that, I get 3 minus 2 times A, which is 3 minus B, is equal to negative B. And in the third equation, I get negative 2 plus 5 times A, or negative 2 plus 5 times 3 minus B, is equal to negative 1 plus 9B. So now I have 2 equations and 1 unknown. Let's simplify these. I can multiply this out and combine like terms, and I get 3 minus 6 is negative 3. I have negative 2 times negative B is plus 2B equals negative B. For the second equation, I get negative 2 plus 5 times 3, or negative 2 plus 15 is 13. 5 times negative B is negative 5B. So I get 13 minus 5B equals negative 1 plus 9B. So now I need to solve for B. In this first equation, if I subtract 2B from both sides, I get negative 3 equals negative 3B. So B is 1. If I plug in 1 into the second equation, I get 13 minus 5 is 8 on the left-hand side, and negative 1 plus 9 on the right-hand side, which is 8 also. So I get 8 equals 8, which is a true statement. Had I gotten a false statement, then I would say the lines do not intersect. But because I have a true statement for both of these equations when b equals 1, the lines do intersect. And I can plug in my 1 in for b to get A. 3 minus 1 is 2, so A is 2. So I don't want the times at which they intersect. I want the point of intersection. So I can either plug in 1 into the second line for t, or I can plug in 2 in for the first line for t, and I should get the same point. Let's check that. If I plug in 1 into the second line, I get negative 1, comma 7 minus 1 is 6, comma, and negative 1 plus 9 is 8. So I get negative 1, comma 6, comma 8. And if I plug in 2 for t for this first line, I get 3 minus 2 times 2, or 3 minus 4 is negative 1. I get 4 plus 2 is 6. And I get negative 2 plus 5 times 2, or negative 2 plus 10, which is 8. And it does agree, I get the same point. So I can say that these two lines intersect at the point negative 1, comma 6, comma 8. And I'm done with the problem.